I see summer rising through the dust, and upon my back a cold wind blows. The night is my reminder of coming quick and less kinder with my age. I feel my time is running way too fast.
Well, this is a nice house for sure. Spiral staircase. We have the coolest supposed to be on. There's no fan on, so we might not have power to the thermostat. We'll take the faceplate off and check, or actually I'll just run up in the attic and check real quick too, because we have some zone components up there as well. You can see already that the damper lights are on, so the transformer feeding the damper just got power. Let's take a closer look at the air handler over there. You can hear the line set, the condenser is running, but no fan motor. And this fan motor was replaced a couple years ago. I remember that because I actually brought my son along for part of the job. Take a look inside. It's toasty up here. We'll see what the variable speed fan motor is doing. It might be nothing. Condenser just shut off, probably because of the freeze stat. I think I added a freeze stat to this system. Then there's an ECM 492 as well, which might be keeping it offline for a few minutes and coming back online. Alright, let's take a closer look here. We got no CFM on the light there. What's our circuit board? We have no CFM on the light there. Let's see if we're getting a signal for the fan. Alright guys, I have my universal Zebra here, and it's going, I'm trying to operate the variable speed fan motor inside directly using these dip switches. So I'm going to turn things on at the disconnect and go ahead and try to get this thing running. So far we've got no action on the variable speed blower. Double check high voltage to that blower. Alright guys, I have my voltmeter here. We'll turn this back on. See what we got. So we have to have power to the fan. We have 120 volts to the fan motor there. We have 120 volts there. So we have power to the fan motor, and it is just not looking very good. And I'll show you something else I saw. We're taking the module off to take a look inside. You can see what's inside of the motor itself. Right here is a module on the inside, a couple of capacitors. We're going to take this off here, this plug, and we're going to ohm out the motor itself to see if it looks good or not. I noticed two things when I came in here a little earlier. I see we have a ground screw there and we have a burn mark next to it. And when I flip over the control board in the module, you can see that there are burn marks heavily in the area where we have our ground. So I'm going to guess that we had a lightning strike, and this would be a great advertisement for those little, you can see, darkened area here, but really, once you see where the ground screw was, and you flip it over, it's very, very damaged in that area. So that's going to be the cause of death for this motor, is more than likely a lightning strike during one of our electrical storms. Okay, cool. I'll give him a call and see what he wants to do. 618. Okay, I appreciate it, Jerry. Thanks. Bye. Expensive. PSC, PSC, PSC. Control board. I got all these wires. The variable speed control board. It's a high voltage to the motor. We have our ECM control board, 255, to control the PSC motor. One comment can go over to the board. There's another space to jump another comment out. .24 volt hot from the transformer over to the board. We'll be reusing this harness that went to the heater section. It plugs in like right over here. Cleaned off the shaft there a little bit. Gonna put some coil on it and take the set screw out. See if we can't get this thing off. We got ourselves a 3/8 on one side, 7/16 on the opposite side impact driver. We'll tighten it up a little bit and then we'll even it out. A little bit tighter. Make it even all the way around. Nice and even. We'll get our set screw in then. Use our service wrench to put in the set screw. Our white is one leg of our voltage. Red, blue, and black are the speeds. We'll go with medium first. Let's check them first to make sure. One will have continuity. These two should be open. And that will be our heat strip if we choose to do it that way. These two are open right now. These two are closed. Go into the heat strip to the blower. Tying in one leg of our high voltage. Our other leg of power will travel to the transformer from the heater and to the relay. I'm going to tidy this up a little bit and then we'll get our capacitor mount. Alright, so we got our blower relay, our capacitor, transformer. Need some of our low voltage hookups here, our common and our red. We can feed that in there when we get up there. Alright, let's go up again. We have all these wires coming over here for the low voltage. I have to chop this plug off and wire them in one by one. Looks like our plug's almost too short. Cut some of our straps back off of it. The best laid plans. got that in there. Go ahead and take the door off the heater. Nothing stops a train, baby. Nothing stops it except everything. You can see our wires here. I want to see which wires are in the plug here. Hey, New York's calling me. That's probably crap. These two go nowhere, so we can cut those off. Goodbye. They have no destination and require nothing. Show what we're looking at. This is the plug we're looking at right here. Those two wires right here don't go anywhere, as you see on the other side of the plug. We have the two wires that come down here for the control voltage. One of them goes to the limit switch, and one of them goes directly to the contactor. So one of them will be W wire, one of them will be common. We're going to splice some of our wiring. Take some of the white wires we cut off here, splice it onto our blower relay board so we can bring it out to the low voltage. Take the red here. We take it directly over to the other red. Coming in from the field connection to the zone panel and heat pump. There we are. And now we'll take the other white. We'll name him Walter White. And we're going to run it over to the common on the blower control board. Which will be right here. We see our blue wire coming in from the transformer. Sandwiched in there we have a kind of like a piggyback connection on it right now. I'm going into that connection if I can. And I'm going to run it out. The main disadvantage to this is if I'm not the next guy here, he might be a little confused for a moment. I'm going to write down what I did, but there could be a little confusion probably. The best thing to do is just hire me again. Reason why you keep the PSC motor instead of going back with a variable speed. One, this guy is selling this house, and two, this would have been the third variable speed motor gone into this equipment. Maybe because of zone system, recycling very cold air. There is a minimum. There's an air temperature sensor up here. I don't know if you can see it, but it senses air temperature. Won't let it go below a certain amount, but still it stays a little colder in there than if it normally would. Okay, so we have most of our wiring is off to the side over here. We don't need the Y wire because we're not telling a variable speed motor to run at a certain speed. So really all we need is red and white and blue and green, and that is all we require. So I'm going to cut some of these wires off, take them off the thermostat wire up here because we no longer need them. So we go to yellow, cut the red wire, cut the blue wire. No longer need orange. So we need 4 wires basically. Green, white, red, and blue. Green is the fan signal. Red is 24 volt hot. Blue is our common wire. And white is for our heat strips. We have a connection broken here via the red. You can see that it might be a little bit too high off in the distances. There we are. We have our red wire broken here. That's on a freeze stat, which is a good thing we have, because when the blower went bad, it would have been cycling the freeze stat a lot. What we can do also is we don't need all of this crud on here. See, all of these wires plug into the back of this terminal board, but all of these whites are unused. It would be better to have them out of the way, and what I can do is I'll disconnect the white here. There it is. Disconnect the white up here. And then I can put a wire nut on it and run it over to the white for the heat kit and go directly to it. Cut out that old copper there so it doesn't snap off. Good nice fresh section of copper wire. We can take it here. And we'll go to top and bottom. Top goes back there, bottom goes. So what we'll do is we're going to hook these both together. Give them a little bit of play so we can strap everything together at the end. And now this will go directly coming in from the zone board to the heat strips. Yeah. That is a little bit unnecessary. Probably could have done it without that, but at least we'll be able to be strapped with everything else now. Alright, we have common. I need to add this to the commons because this is going to the heat kit. Alright, we have those now. Alright, so we have our red going to the transformer and zone board. We have our common going both to the contactor and back to the fan control board, and then by extension goes back to the transformer. Our green is the only one left. And that'll be traveling back to fan control board. Make sure I'll stuff it backwards just to make sure it'll fit. So I have a stake on the other end, just in case it doesn't fit. It's tight, because we've been cramming lots of wires. We'll go ahead and connect this stake on to the G terminal. And this is actually a control board that's used on a lot of train systems. Fan delay, just not used on variable speed, obviously, because they operate in a different manner. They have the zone board, or the control board we took out for the variable speed motors. The GE 2.3, I think. Alright, so this green's going all the way back to the control board. So let's check through and see if we got everything. Alright, we got our transformer hooked up. A high voltage comes in, goes out through here, comes around, goes to the fan control, goes to the transformer. Good. The other leg goes to the transformer, and then in turn go directly to the fan. We have two wires not used, which is our other speeds. We have a whole dangling mess of crap here, which we will put together. Let me button this back up, and you guys can catch up with me after that. Our fan is operational. We're calling for cooling on zone 2, looks like, and I'm sure the other zone will click on in a minute. So far so good. I'm gonna button it up and we'll see how we're doing. Take an amp draw on that motor. A few minutes we'll click back on. We'll have us a little bit of air conditioning. If you listen, guys, you can start to hear the refrigerant traveling through the lines, which is good. Our temperature is 87 starting out. It'll start dropping when it senses the supply cooling off there on our sensor, which is right here. So we should start dropping 85 and run about 10-15 minutes, and it should settle out to the correct supply temperature. We'll let her roll for a minute and see how she does. As you see, guys, we're climbing down low really quickly, and if you look here, one zone is calling. That's why we have our reversing valve light, fan light, compressor light right there, all aptly colored. We go up here to zone 1, it's not calling yet, so it's going to get a very big temperature spread because we're recycling air through the bypass duct. It's all the way open. There's our static pressure switch. It's telling it that the static pressure is high and it needs to recycle air, and that's what it's doing. So we need to open up the larger zone, the main floor. Both zones are calling now, guys, so you see the bypass is shut because the static is in normal range. We have 64 degrees coming out, about 20-degree temperature split, still a little bit on the high side, but with the level of air noise from the extremities, that's where we're going to stay. We could probably bump it up to high and get a little bit closer to 400 CFM per ton, but for today and for the level of noise, and no one's going to buy a house when the registers squeal like pigs. So we're getting a decent amount of airflow, we'll say that. It's not very scientific sounding, but it's doing okay. I'm gonna let it run for a few more minutes while I am picking up my stuff, and then I'll shut things down one time just to make sure everything shuts off like it should, and then we will turn it back on again.